I really enjoy this. I think we should just listen to country music.
I should just teach music instead of math.
Oh,
I could do that.
Yes.
We could do that. Wow. Wow. The things I do for my students, give them new brains, play terrible music, play good music. That was a great song. All right, so yesterday what we did was we talked about all these different triangle stuff. And again, it looks really overwhelming when it's all together. So here's what I'm going to do. Yes, Corinne.
Just to watch the country film.
Yes.
That's all.
You know, I've ever closed on ever filth again. It would be the last one you say.
Maddie, are those new glasses? They are, right?
No.
No? They look very nice.
I just didn't feel like putting contacts in my eyeballs.
Okay. All right, so anyway, all this at once is kind of overwhelming. But somebody tell me what it means to be a perpendicular bisector. Yep, hits at 90 because it's perpendicular. And what else?
You can make a circle around it.
Perpendicular bisector. I got perpendicular taken care of. What's the bisect part of it? Nope. If it was a bisects the angle, we call it an angle bisector. It bisects the segment, right? So here's a triangle. I'll draw you one.
I don't want to go with
There we go. The old acute triangle. All right, so what we want to do is construct some perpendicular bisectors. That means 90 degrees, right? And then it bisects the sides. So we need to find the halfway point for all our sides, right? So these are perpendicular. This is the symbol for perpendicular. Bisectors. So this looks about the halfway point for this side, halfway point for this side, and halfway point for that side. And then from these points, I'm going to go 90 degrees straight up, right? So this looks about 90 to me. Let's use red. Actually, that looks more about 90 to me. Right? So that right there, that red line that I just drew is a perpendicular bisector. It's called a perpendicular bisector because it's perpendicular and it bisects the side, right? So says me. Same thing with these other sides. Is everybody cool with just that one?
Yeah.
Okay, cool. Again, I think things get overwhelming when we draw them all at once. The minimum I need to be able to find the center that they make is 2, right? 2 lines intersect, I've got the point, the third one will intersect with it. So, here's what I'm saying. If I've got 2 lines that intersect, we call those lines concurrent at that point. And if I know the other line has to intersect there, right? Do I need that other line to establish where the dot will be? No, it's already established, right? 2 is enough to get the job done. So I won't draw all 3. Which one do you want? Left side or right side one? Left side or right side? Don't all answer at once.
Right side.
Right side. Thank you, Maddie. All right.
What?
You're just quick. Just very,
You said don't all answer at once.
I know.
I have to say something.
Yep. You are feeling it today. All right, so those are 2 perpendicular bisectors, and they intersect here. Cool. So that center we call the circumcenter. Because it's the center of a circle, right? Circum means to go around, right? To circumnavigate, right? So when we talk about a circumcircle, we mean a circle that goes around the triangle. So this center right here is the center of this circle I'm about to draw. And I'm going to try and do it with a compass. We'll see. This one's not the nicest, but we'll try. And again, I estimated my center. But in general, if I draw a circle, it should, if I got the right point, hit all the sides of my triangle. Now the reason my point's not accurate is because I estimated the halfway point of all these sides, and I estimated 90 degrees, right? But in general, that'll be the center of a circle that goes all the way around our triangle and hits every single vertex. So I'm going to draw a real crappy one now. Something like that. Okay? So that's a circumcircle, or a circumscribed circle. What does scribe mean? when I say the word scribe, what does that mean? To write or draw, right? Either or. So when we say circumscribe, we mean drawn or written around something, right? Circum means to go around, right? So it's a circle that goes around the triangle. So far, so good? Right? Perpendicular bisectors because they're perpendicular and they bisect the sides. Circumcircle or circumscribed circle because it goes around the triangle. Now, if we have a circle, what should we have? What kind of lines always occur with a circle? Radii, right? Radius. Now, I could draw a line from here to any point on this circle and it would be a radius, right? That's what a radius is. But the ones that are interesting are the ones that are inside the triangle. Notice because these points are all on my circle, if I draw a line to them, those lines are all going to be the same distance because they're all radii. So they're all congruent. And that's it. By the time you get done, it looks like a lot, right? I throw this in front of you and you're like, oh my God, what happened here, right? But if you take it piece by piece, it's not so bad. Perpendicular bisectors. They intersect at the circumcenter. That's just something you got to know, right? And then the circumcenter is going to be a circle that goes around the triangle. And so we have radii. Are you feeling okay? Maybe not 100%, but you feeling okay? All right. Again, I don't want you to be overwhelmed. If you take it piece by piece, it's not so bad.
Me? I had a cough for about 17 years.
Pretty sure I have coronavirus.
Give me another triangle. Uh-oh. Would you be here all day? Oh no.
Gravity.
There we go. Gravity strikes again.
When they invent gravity. I'll inform you on the joke later.
Okay, please do. All right, so we've got another acute triangle. So, next one's the orthocenter. Why do they call it the orthocenter?
Because it's close to the orthodontist.
Good joke. Why do they actually call it the orthocenter?
You said something about the orthodontist and it being close.
So when you think ortho, right, you might think orthodontist, and orthodontist straightens your teeth. So it has to do with these 90-degree lines, right? Right? The word diagonal, you guys know that, right? Diagonal means like this. Orthogonal means straight up. Okay? So that's where it comes in at 90. So when we draw an orthogonal, what we're really drawing is the height of the triangle, right? So if I go straight from here down to the bottom, I can go lots of different ways, right? I want to go straight down at 90. So it looks like to me that this would be about 90. So there's our orthogonal that we just drew. And I can do a couple more. I can do all three, but again, we only need two to find the center, so I'll only do two. I'll rotate my triangle so it's easy for me to see the height. Looks like this. Those are my orthogonals. And where they intersect, what center is that? Come on, orthogonals, guys. What center? Orthocenter. The orthogonals intersect at the orthocenter. That's why they call it the orthocenter. It's the center of the orthogonals. Cool. Now, there aren't a whole lot of interesting properties about the orthocenter, but we do get some similar triangles, and we'll talk about that later. That's the most boring one. It's all the heights of the triangle. Another acute triangle. What's the next center on the page? Thank you, Ivy. The end center. And what kind of segments do we have to draw to find the end center of a triangle? Anybody know that? Angle bisectors, right? Why do we call them angle bisectors? They bisect the angle, right? So what I'm going to do is I'm going to take these angles and I'm going to cut them in half. Now I could measure with a protractor, figure out how big they are, right? This angle right here looks like 45. If I cut that in half, right, I get 22 and a half. Looks about right here. So I'll cut that angle. So we've got 2 equal halves there. That's how you know this is an angle bisector. I can measure this one out if I wanted. Looks to be about 70, so about 35 degrees is where I want it. And I could draw all 3 of these, but again, I only need 2 to find where the center is, because where they intersect will be here. If I were to draw the other one, it would go through there. So those are my angle bisectors. And where they intersect, called the incenter. So we have got angle bisectors. And where they intersect is the incenter. Why do they call it the incenter? Yeah, the circle's inside. It's the center of an inscribed circle. Remember, scribe means to write or draw. In means inside. So we're going to write or draw a circle inside the triangle, right? So we've got an inscribed circle. So I'm going to draw that. Let me try to use the compass. That was fun, right? Maddie had so much fun. Which one indeed? Oh, I need to find a perpendicular to figure out how big to make this. We're going to estimate this as perpendicular. Ah, I overestimated. That's not bad, right? Thank you, Maddie Shelton, Blake Shelton's daughter. Something like that. Cool, so we got an inscribed circle. That's what this guy is. Ladies in front, if we have a circle, what kind of lines do we know we have? Someone other than Ivy. We have a circle, just a circle. Just imagine a circle. What kind of lines do we know we have?
Perpendicular.
Radii.
Thank you.
That's what I meant. I kept saying bisectors. I meant radii. I'm so.
So from here to the sides are all going to be radii. And they're all radii, so that means what about their lengths?
Don't say.
So the incenter is the same distance from all the sides of the triangle. So here's why we have multiple centers, right? You might say, oh, I want the same distance from all the sides. That's this guy, the incenter. You might say, I want the same distance from all the vertices. That's a different center, right? And then the last one you might want is, I want the balance point, right? The center of mass. Well, that's a different center as well. How do I find the center of mass, the balance point? The medicenter, the centroid. It's really not. It's what we've been doing the last couple of days. We will have a quiz over this next week.
A squared, B squared.
Nope, thinking too hard. Medians find it.
Centroid and
Medicenter, right? Medians, medicenter, centroid, whatever you want to call it. What is a median? Vertex to midpoint. Vertex to midpoint. All of these are centers, Eads. Depends on what we're talking about, right? If we want to know the center that's equidistant from the vertices, it's this guy. If we want to know equidistant from the sides of the triangle, it's this guy. If you want to know the balance point, well, it's not going to be either of these. It's going to be this guy, the medicenter, or centroid. And the way we find it is we make medians. And Maddie correctly said medians are vertex to midpoint. So I need to find my midpoints. Let's see, I can measure it out. I'm not gonna. I'm just going to estimate. Looks about right here. And I can do the same thing for this side, but I only need 2, right? So I'll connect from vertex to midpoint. That's one median. And here's another. Went too far.
So this is finding the median or the
Finding the medicenter, yeah. Or centroid if you want to call it that. And that's the balance point on the triangle. So if I were to give you a block, right, triangle block, and you wanted to find the balance point, like if you were to take that triangle, cut it out, right, you could find the balance point, stick it on a nail, and it would perfectly balance, right? Yep, the centroid or medicenter. I like medicenter because it reminds me of medians, which is how you find it, right?
So what are you saying
Wow.
Can you say it?
Medicenter. And on top of that, we know that this will be twice as big as this, always.
2-to-1 ratio.
2-to-1 ratio, exactly, right? But this is the center of mass. So, where'd my, there it goes. And that's what you did, right? The perpendicular bisectors, that's what you got to draw to find the circumcenter. right? The center of a circle that goes all the way around. So if you wanted to put this triangle inside a circle, right, the perfect way to do it would be to find the circumcenter and then measure from here to here to figure out how big your circle would have to be. Orthogonal is not very interesting. We'll be talking about that next week. And then the incenter is if you wanted to fit a circle inside a triangle, that's what you need to find. And if you wanted to balance the triangle, you'd want to find the medicenter, because it's the center of mass, and you draw medians to figure that out. So, I got some graph paper for you. Now it's your turn.
This class went by fast. We only have 19 minutes left.
Actually, we gave them playing some songs for some girls here that are still not waking up to pay attention to class.
Yeah, Maddie Sanders.
So good at these.
Someday.
Hi, Gwen. Gwen actually ignored me.
I love her.
Are we gonna do our packet?
My favorite.
I don't know.
Possibly.
All right, first thing you're going to do, take out a pen, marker, whatever you got, and draw yourself a triangle. I would highly encourage you to draw a acute triangle, because then all of your centers will be inside of it.
I don't really, just regular triangle.
Yeah, regular triangle, acute. Not right, not obtuse, just acute, right? All the angles less than 90. You should have protractors on your desk.
I got the short end of the stick. I don't have one. Yeah, me too.
Grab one from one around you. Or maybe they put them all away, 4th hour.
What am I screwing right now?
I think it's a triangle right
I think I'm gonna fight someone.
Here, you take those, go on.
Perfect try.
Your next class. I have one for every desk. Oh, they're all up there.
All right, let's get it.
All right, so I'm going to draw a triangle like this. All angles are acute. They're all less than 90, right? That guy's smaller than 90, that's smaller than 90, that's smaller than 90. It's approaching 90, right? But not quite. All right, so first thing I want to do is I want to find the centroid. Centroid's the balance point, right? So if I were to cut this triangle out and wanted to balance it on my finger, this is the point that I need to put my finger on. How do I find the centroid?
Did you draw your lines?
Draw your line.
We're going to need to draw lines, but what lines?
Perpendicular.
Remember, another name for the centroid is the medicenter.
Oh, maybe I'm wrong.
The
Yep.
midpoints of those segments.
There's too many. I'm confused.
I don't know. I don't think I said that right, but I know what I'm talking about.
Trying to do.
You know, we've got 4 different centers with 4 different lines to make them. I'll spell it out for you. The medians
Angle bisect.
go with the medicenter. That's how you find the medicenter.
So nice.
We're going to find out in a second. All right, so medians go with the medicenter. Angle bisectors go with what center?
Angle bisectors go with one graph of the bottom.
In center.
I'm so sorry. I'll leave.
Perpendicular bisectors. What center do they find?
Perpendicular is the one where it goes with the one that's the longest.
Circumcenter.
Most complicated.
And then lastly, the orthogonals go with what center? Yeah.
We're just trying to find the middle.
Yeah, we're trying to find, well, all these are the middle leads, right? Depends on what we're talking about. Do we want the middle that's equidistant from all the vertices, right? The same distance from every vertex? Or do we want the middle that's the same distance from all the sides? Or do we want the middle where we can put our finger and balance it, right? It depends on what you're looking for. So I want the balance point. Which one do I need to find? What center? Medicenter is the center. Medians are the lines.
What's the last one say?
Okay. I think you guys are being careless with your answers. right? I need you to think just a little bit more. I know you might not know all of it, right? But you should know that the medicenter is the center when I'm asking for a center, right? Not a median. None of these say center on them, right? Those are all lines. All the centers say what? Center.
Is the last one orthocenter?
Yep, orthocenter. Yep. So I want to find the medicenter, right? Because that's the balance point, centroid. You can call it that if you want. So I need to draw medians. What is a median? Midpoint to vertex, right? So first we need to find the midpoint of your sides. So do that. Find the midpoint of the triangle you made. You can either measure with your protractor and be exact, or you can eyeball halfway. The bottom here is about 3 inches long, so I'll go 1.5 inches, and that'll be about exact. Make sure you mark it as a midpoint when you're done. And once you found one of the midpoints, you can connect it up to the opposite vertex, and now you've got a median, right? So by drawing this line, which I'll do in pink, that's a median. That line. Now all of the medians will intersect at one point, but if you want to be lazy like I am, I'm not going to draw all my medians. I'll just draw 2 of them, right? How do I find the other median? How do I find my other median? Vertex midpoint, right? So I find a midpoint of another side, right? It's like about 2.5 inches, so I'll go 1.25. Yep, vertex to midpoint. Vertex are the points on the triangles, right? The point of the angle. And the midpoint's the point we found. It's called a midpoint because it's halfway between the 2 vertices of the triangle. So now I know, right there must be the balance point. That's the medicenter.
Oh, I had to restart it. I totally messed this up.
That's it. Not a whole lot of interesting stuff about the medicenter.
Next time.
Only fact that we know is that this is 2 to 1, right? And it's the balance point. So if I were to cut this out and put my finger right there, I'd be able to balance it perfectly. Cool. Let's do another triangle. What do you want to do next? Find the in-center, circumcenter, or orthocenter. In-center, right? So draw yourself another triangle. Acute's the easiest because that'll mean your centers will always be inside. Now, these 2 that we're drawing, it won't matter though. Because the medicenter is the center of mass, right? It's the balance point. The balance point is always going to be inside the triangle. And the in-center is called the in-center because it's inside the inscribed circle, right? So the circle is going to be inside, so the center will be inside. It doesn't matter what triangle we're talking about, right? But these other 2, different triangles might have a center outside the triangle. All right, so now we're going after the in-center. How do we find the in-center? What lines do we have to draw? What lines do we have to draw to find the insector or the in-center? Angle bisector. So we got to bisect all these angles, right? So if you want, you can measure your angles, or not. You can estimate if you want. And this looks like 50 degrees for me, so I'm going to cut it to about 25. Put a dot, and then I'll draw a line between my vertex and that dot, and it'll bisect the angle into 25 and 25. So I put my circle right in my protractor on the vertex, and then that bottom line on the bottom line here. And then I can look at my protractor And it says 50 degrees, right? Going from 0 to 50.
When's that 60?
Well, halfway there is about 32 and a half, right? For me, it was about 25, right? Half of 50.
Can you put a dot in the middle?
I put a dot where my protractor says 25. That way I can draw a line to it later. Does that make sense? That dot is not the center.
So like that.
Yeah. And I need two of them, right, to figure out where the center is. So I'll go to my other side and I'll do the same thing. Now I'm reading the protractor backwards. Looks like from here to here is 60, right? Pretty good at drawing these exact angles. So I need 30. So I'll put a dot right there on 30. Right? So I measured from here to here. That's 60. Right? I put my dot on the vertex and lined it up. So that's a 60-degree angle. Half of that's 30. So that's where I want to draw my line so I can cut the angle in half. See how it cut this angle in half? And where they intersect will be my in-center. So the last center we found was the balance point, right? This center is the one that's the same distance from all the sides. So the distance between here and here will be the same as the distance between here and here. Will be the same as the distance between here and here. Do you see how that center is the same distance from every side? Right. That's why we call it the in-center, because it is the center of an inscribed circle that fits perfectly inside here. I'll try again with the compass. This time I sort of measured.
Ooh, I just drew a perfect circle.
Wow. Looks like so did I. Oh no, I moved my compass. Drawing these small circles is hard.
He's got an inch finger.
Yeah. Can you make this lead a little bit longer? This thing at the top's getting loose. Alright. So there it is. Right? It's the in-center. It's the same distance from every side. Notice it's not the same distance from every vertex though. Right? These distances are all different. If we wanted to find the same distance from every vertex, we'd find what center? Circumcenter. Same distance from every vertex means we have a bunch of radii, right? So we're going to get another circle. We've already done the in-center, the inscribed circle. So now we're going to do the circumcircle, the circumscribed circle. Everybody cool with this one? Bisector angles, where it intersects, will produce a perfect circle inside the triangle. Same distance from the sides. Let's do another. Let's find the circumcenter. What lines do we need to draw to find the circumcenter? Perpendicular bisectors. Not just perpendicular, but perpendicular bisectors, right? It's all good.
Can this be any triangle?
Oh, it's true.
I'd prefer acute because for the perpendicular bisector, the center can actually end up outside.
What one we doing?
We're doing the circumcenter. And the way we find that is we do perpendicular bisectors, right?
I suck.
What is a perpendicular bisector? Why do we call it that?
Perpendicular.
Right? It's perpendicular. And what about the bisect part?
They bisect at a perpendicular.
Yeah, they bisect the sides at a perpendicular angle. Good job. So if they bisect the sides, what we're really saying is midpoint, right? So I'm going to find the midpoint of my two of my sides. I'll measure. Looks like 3 inches, so I'll go 1.5. And then over here, looks like 2 3/4. So I'll go 1 3/8. Oops, that's not right. 1 6/8. Neither of these are right. About right there. Now when I draw these, I'm not drawing medians. Remember, median is from here to here, right? What I'm drawing is from that point up 90 degrees. Wherever it lands is wherever it lands. So I'm going to put it right on there. And there's 90. So when I draw my line, I'm going to go from here to here. It's not supposed to go through the vertex. It goes wherever it goes, right? So I'm going to go from the midpoint on this side, straight up to 90. Looks like that. I could draw the third one, but why? I already know where my center is. It's right here. This is a circumcenter. Circum means to go around, so there's a circle that goes all the way around this triangle. It hits every single vertex. So let me see if I can find my compass. This one should be a little bit easier to make. So from my center, all the way out to here. Not bad. Not great, but not bad. All right, if there's a circle, what kind of line should we expect? Radii, right? So if I draw from here to any point on the circle, I should get a radius. So that means this right here is a radius, and this right here is a radius, and there's a radius, which means that the circumcenter is the same distance from all the vertices, right? So in center is the same distance from the sides. And circumcenter, same distance from the vertices. Guys, next week we're going to pick up the pace a little bit. Have a safe weekend. Yes. Not yet. Yeah, you had good attempts. Go put your stuff away, come on back. I am not under the impression that a little bit more effort would make everything, just illuminate for you. Like everything would just be easy after that. But I do think a little bit of effort would go a long way with this. I think some of us in here are giving more effort than others. I need a little bit more out of you. I think that's fair.